Hello everyone, and welcome back to the Fluctus Channel. The Boeing B52 Stratofortress is the largest and longest-serving strategic bomber in the United States military. Conceived in the early 1950s, the B-52 offers a range of nearly 9,000 miles and can carry up to 70,000 pounds of weapons. The B-52 has received extensive upgrades over the decades, allowing it to remain operational in combat scenarios to this day. At 159 feet in length and with a wingspan exceeding 180 feet, few aircraft appear more imposing than a fully armed Stratofortress. While all military aircraft undergo pre-flight inspections, the age of the standard B-52 adds added significance to pre-flight procedures. The B-52 is powered by 8 Pratt & Whitney TF-33 engines, each generating approximately 17,000 pounds of thrust. These are turbofan engines, meaning they feature both a fan and a turbine that drive the compressor. This engine model is renowned for several qualities, including exceptional durability and reliability, which are critical for powering a long-range bomber, such as the B-52. Another attribute of the B-52's engines is that they require a long time to reach operating temperature for flight. However, as the Stratofortress is a strategic bomber, there may be occasions when it must become airborne much more quickly. In this method, several cartridges, similar to large shotgun shells, are loaded into the engines. These generate a large volume of pressurized gas almost instantly, turning the compressor to start the engine immediately. When detonated, the cartridges release massive smoke plumes from each engine's exhaust. Though there is a fire risk if mismanaged, a cart start can have a B-52 airborne in under 10 minutes. A further distinctive feature of the B-52 is the minimal rotation observed during takeoff. Rotation refers to lifting the aircraft's nose off the ground as it accelerates. Yet, because the aircraft is so large and heavy, little noticeable rotation occurs, giving the appearance that the front and rear wheels leave the ground almost simultaneously. In reality, the tail cannot produce sufficient downforce to lift the nose, especially when the bomber is fully loaded. This minimal pitch is mirrored during landing, with both sets of tires contacting the runway almost simultaneously. The B-52's fuselage is narrow, so the front and rear landing gears sit only a few feet apart. This makes landing the Stratofortress particularly challenging, especially in crosswinds. Depending on the aircraft's weight upon touchdown, it may require at least 7,000 feet to stop safely. Drag chutes are frequently deployed to aid in bringing the aircraft to a halt. The B-52 has a reputation for being somewhat maintenance-intensive. This is particularly true for the TF-33 engines, which require routine servicing to ensure peak performance and safety. The frequency of maintenance for each engine depends on factors such as age, flight hours, operating conditions, and maintenance history. In some instances, entire engines are swapped for reconditioned units. The removed engine is sent to a specialized Air Force refurbishing facility for overhaul. Maintenance crews also focus on the aircraft's structural components, performing tasks such as corrosion removal, hand-forming parts, and cold bonding to repair panels and doors. For over 60 years, the Boeing B-52 Stratofortress has remained an enduring emblem of American air power. Its enormous wings, 8 engines, and global reach are widely recognized, but inside lies a complex world. The B-52 cockpit and crew stations are a sophisticated array of switches, gauges, and controls, reflecting the aircraft's long history and ongoing modernization. Despite the design's age, stepping into a B-52 flight deck feels like entering a time capsule. The space is larger than modern fighter jets, but packed with extensive analog instrumentation. Rows of round dial gauges occupy panels in front of the pilot and co-pilot, providing critical information continuously during flight, including engine temperatures, fuel flow, hydraulic pressures, and electrical output. While digital screens and new avionics have been added through upgrades, many original analog systems remain in use due to their proven reliability. The pilot occupies the left side of the forward deck, with the co-pilot on the right. Between them runs a central console equipped with throttles for all 8 engines, trim wheels, engine start controls, and numerous switches controlling navigation and aircraft configuration. Unlike modern fly-by-wire planes, the B52 uses mechanical linkages and powered control systems. The control column, yoke, and rudder pedals transmit the pilot's movements directly via cables, boosters, and actuators to maneuver the massive control surfaces. Behind the pilots sit the electronic warfare officer and radar navigator, forming the Mission Management Center. The electronic warfare officer operates systems for detecting, analyzing, and countering threats using screens, tuning knobs, signal processing controls, and jamming interfaces. While technology has advanced, the station still features physical switches for precise manual operation. Nearby, the radar navigator manages offensive systems, operating targeting radar, configuring weapon delivery, and running the mission navigation suite. Lower in the fuselage is the navigator station, historically home to manual plotting tools, paper charts, and celestial navigation instruments. Although satellites now provide precise global positioning, the station retains many original fixtures, including offset bombing equipment and communication panels essential during Cold War operations. Throughout the B-52, redundant electrical systems, hydraulic networks, and fuel management panels require meticulous hands-on operation. Many tasks automated on newer aircraft still depend on deliberate crew action. This manual approach contributes to the B-52's need for a large crew, typically 5 to 6 members, depending on mission configuration. Even with modern upgrades such as new radios, digital flight computers, and improved threat detection, the cockpit's core remains analog. Its analog controls have proven reliable across environments from Southeast Asia to the Middle East, and its crew stations remain central to delivering long-range strike capability worldwide. Through these stations and controls, the B52 Stratofortress persists as one of the most resilient aircraft in history, showing that well-engineered systems and skilled operators can maintain relevance across generations.
Is APU battery checked in?
Boeing B52 Stratofortress today represents a remarkable blend of heritage, engineering, and modern military adaptation. Its massive wings and unmistakable profile continue to dominate airfields. But it is crew discipline and design resilience that keep it in active service longer than any other American bomber. From detailed pre-flight inspections to complex management of engines, flight controls, and analog systems, every phase demands focus, teamwork, and technical expertise. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.